This Math 8 video is on the real number system. The real number system is just a way of classifying numbers. So if you think about, like in science, you can classify animals. You can put them into different categories of animals. That's basically what we're doing here with the real number system. Every single number we deal with in Math 8 will be a real number. You won't get into imaginary numbers until some higher level math classes. So every single number I give you will be a real number. That's something to keep in mind. So as you can see, we have these 5 different subsets: natural, whole, integers, rational, and irrational. Natural numbers, this is the smallest or the most specific circle, as you can tell, the most or smallest or most specific subset. Natural numbers are counting numbers. That's a definition. So when you're counting, you start and you go 1, 2, 3, and so on. That's exactly what natural numbers are. Whole numbers starting at 1 and going up. Let's move on to whole. So if you notice, this is very important, this natural circle is inside of the whole circle or the whole subset. So that means that every single natural number is also going to be a whole number. The only difference with whole numbers is that it includes 0. So 0, 1, 2, so on. So whole and natural numbers are very similar. The only difference is that 0. Let's move on to integers. So as we are getting, we're spreading out, more and more numbers are included. So integers are positive and negative whole numbers. We're still dealing with whole numbers. So negative 10, negative 30, 5. That's another example of an integer. That's a positive whole number. Our final subset over here on the left side of this diagram is rational. Rational numbers are basically any numbers that can be written as fractions. You could have 12 over 5. You could have 2.33 repeating. You could have, 2/3. Those are all examples of rational numbers. You could also have 2. 2 is rational. But 2 is also natural, so on a quiz or a test, if I ask you what the most specific category for 2 is, you would put that down here with the natural numbers. Let's move on to irrational numbers. So as you can tell, irrational numbers are kind of out here on an island on its own. Any number that's irrational is not going to be natural, whole, integer, or rational. It's kind of over there on its own. A common irrational number is pi. 3.1415 ... goes on forever and ever. Irrational numbers are decimals that don't repeat and they don't terminate, which means they go on forever. You could have the square root of 2. You could have just 2.1234228. I don't know, I just made that up. It goes on and on forever, not repeating. I could also give you a table like this. I could give you some numbers over here. Let's look at the square root of 9. The square root of 9, you might look at that and think, oh, it's a square root, so that means it's going to be irrational. Not so fast, though. The square root of 9, what is that? Hopefully you can tell me that the square root of 9 is 3. So let's think about what is the most specific category for 3. Well, when you think about counting numbers, 1, 2, 3, 4, 5, so the most specific category for 3 is natural. So if it's natural, we know that it's also whole, it's also an integer, it's also rational, and I mentioned that every single number we deal with will be a real number. Let's look at one more example. Let's maybe do negative 12. Negative 12, let's see, we know natural numbers are whole numbers, so that works, but negative 12 is not a counting number, so it's not going to be natural. Let's move on to whole numbers. So whole numbers are the same thing as natural, but it's also including 0. Negative 12 is not in that category. Integers are positive and negative whole numbers, so negative 12 is an integer. Because it's an integer, it also means it's rational. And because, it's a normal number, or, it's not imaginary, it's going to be a real number. Every single number we deal with will be real.